Hello, good day. So I'll be taking a course, Mobile Application Reverse Engineering. So basically, this is an introduction to Android app reverse engineering. It was initially scheduled to be an online class, uh, but due to some unforeseen circumstances, we couldn't have this class again completed. So I'm having to do recorded videos and put on YouTube for the course participants. Okay. So basically, every day we see lots of new Android applications being published to Google Play Store, games, utilities, banking applications, IoT device clients, lots of applications that uh, interface with our everyday life. We control via an app. So basically, this makes life easier, smarter. Yeah, but are these applications secure? So that's what we're looking at during this course. Testing Android applications, reverse engineering them to answer this question of security of Android applications. So this course is just a collection of tricks to reverse engineer Android applications for effective code analysis because that's the end game to analyze the code and see if it meets security standards or if there are inherent vulnerabilities, commonly known vulnerabilities. So I wouldn't be going very deep into technical details. So like I've stated here in the outline, the course is not for you if you're looking for something that will teach you mobile application programming. Uh, the course is not for you if you're going to be looking for how to jailbreak or root Android devices, however you call it. Uh, okay, and then what you need, the course also wouldn't make you think. It's just to show you how to do, not how to think. So it's a very practical course. For prerequisites, a couple of things we're needing: just basic information in information security, basic knowledge in information security, common security concepts, development background, basic knowledge of Android development platform. Yeah, very much required. So you could understand Java when you see it or Smalley code. Also, you need a laptop with either Linux installed. It's easier when you're working with Linux. You could as well do all this reverse engineering from Windows or for a Mac, but it's easier when you're working with Linux or a Apple or a Mac device. Then a couple of tools listed out here. Uh, Okay, so we just need to go. Links are already here. Go to GitHub, clone or download the releases for these tools listed here. Uh, so I'm just going to rush down to what an APK is and explain basically what an APK is. So an APK is an Android package. Uh, Basically, that's what it means. So shortened to APK, Android package. Yeah. Essentially, it's a zip file containing compiled code, resources, signature, manifest, and every other file that the application needs to run on your mobile device. So being a zip file, it's pretty straightforward that you want to unpack it as a zip file. Uh, so I'll just uh, do a quick rundown. Okay, so I have couple of okay, uh, I have a couple of APK files. I'm just going to quickly show you one. AP APK. Okay, okay. I should have okay. I should have a file somewhere here. Can't seem to find it. Okay, I think I'll just work with what I have here. Uh, just a second. Okay, awesome. So this is an APK file. Uh, just treat it as an APK file. Like I said, since the APK file is a zip package, we're just going to simply use the unzip command. Unzip. Uh, APK, then the directory we want to unzip it into. So let's say tests APK. Okay, we should have a new folder, test APK here. Okay, so basically, this is our APK file. So I'm just going to run it through basically most of these folders and explaining what they are. So inside this APK file, one of the first things you look out for is your Android manifest file, which is this, the Android manifest file. Okay. So this Android manifest file is basically a binary representation of the XML manifests, describing what permissions the application will require or request in order for it to run. So bearing in mind that some of the permissions requested at runtime by the app may not be declared in this manifest file though. But then what activities like as in GUIs are there, what services are running in the background, what receivers, classes that can receive and handle system events such as boots, SMSs coming in, notifications, and all that. So once you have this file, it should look later once decoded. Okay, I'll show you how it looks like when decoded, possibly maybe in the next video. But then we'll look at other folders. So there's the asset folders. Now this folder assets contains application specific files like audio files that the application may need to play, custom fonts. When reverse engineering an Android application, this is not really important unless in your code you find specific reference, a functional reference to these files in the assets folder. But you can as well go through it yourself. Go through the assets folder. Okay, then okay, yes. So next folder we're looking at is the resource folder. RES. Yeah. So all resources like activities, XML files, images, custom styles, every image that is loaded in the application, custom files, styles are all stored in this resources folder. Okay. Then we have the resources.arsc folder. This is like the index of all resources. So each resource file is assigned to a numeric identifier that the application will use in order to identify specific entry points into the application. And this resources or ARSC file maps these files to their various identifiers. Nothing pretty interesting about it. Depending on the purpose of your reverse engineering, but nothing really interesting about it. Then there's the classes.dx file. Now this file contains the Dalvik bytecode of the app. Now Dalvik is the virtual machine that Android applications run on, right? So let's say your Android application is developed using Java. The Java source code files are then compiled into bytecode, which your Dalvik VM would understand and execute for the program to run. So pretty much what happens when normal Java programs are compiled to classes file, then they're not compiled to the DX file that the Android application would run. And this file contains the logic basically that the Android application runs on. So sometimes if the classes of DX file is very large, it's broken into two, so you have a classes to the DX file. Because the DX format has a limit to the number of classes you can declare. You have a single file. So basically that's it. But since we're going to be using other tools to reverse this particular file, reverse the APK, we would not really have to pay much attention to this. And there's the lib folder. Okay, so sometimes an application needs to execute native code. Let's just look at it. Okay, so if you see there's EABI v7a. So sometimes your application needs to execute native code. It can be an image processing library, whatever it is. But basically native code that interacts with the hardware directly. In such cases, you find those files inside this lib folder. So ELF files we found here inside the folder as well into specific architecture. So like this one we're seeing now, the ARM EABIV78 is an ELF library. Okay. Then we have we still just to run through. We have the meta.inf folder. So every Android application needs to be signed with a developer certificate in order to run on the device. And so even debug builds are signed by debug certificates. So production builds, debug builds, they all sign with a certificate. So this folder meta.inf contains information about the files in the APK and about the developer basically. So inside this folder, let's see, should have set.rsa, set.sf, set manifest.mf, and then properties for. So the set file is like the manifest.mf file, but it's signed with an RSA key. Then the set.rsa file contains developer public key used to sign the set.sf file and a digest. Okay. So now these are very important files to guarantee the integrity of the APK file, your APK. So as a reverse engineer, or if you're going to be doing malware analysis, it will be very important to analyze this folder, the files in this folder, to be able to provide attribution to the author or developer of the malicious code, which we'll do later. But then, just a quick way to get information about the developer, you can open SSL command. So open SSL let's pkcs7, yeah, I think that is dash n. Okay, so let's say that will be meta.inf set.rsa dash inform. I think the no, that should be a P. Oh, I think I did something wrongly. Okay, so this is the public key. It's supposed to be something else I'm looking for. Just a second, I'll try to figure it out. Hashtags. No. Oh, okay, that's something underscore. No, that's not what I'm looking for. Apologies, I can't remember the exact command. No. No. Okay, I can't remember exactly what it is now I'm looking for. If I remember, I might have to reduce again. But then I was trying to check information about the certificate. Okay. So we're supposed to have an output with certificate information, the public key, the issuer, and all that version and algorithm used. But apologies, I can't seem to remember that. But then, so this is basically about the folder after extracting your APK file. But then, how do you get your APK? So there are multiple ways to get the APK file, which I'll be showing in the next video. Please follow up with the next video. Thanks.